Hello everyone, I am Sunil Yadav. I am a seasoned database administrator with years of experience on Oracle e-business suite, Oracle core databases, implementation, upgrades, tuning, migrations, maintenance, patching, cloning in different industries like telecom, banking, retail, and various other places. I worked on many non-Oracle databases as well, like MS SQL Server, MySQL Server, MongoDB, little bit of data analytics, Golden Gate, ODI, and some other integrated software technologies across different continents. So here I am. I'm going to talk about this topic of ML, which is machine learning, powering databases resilience via predictive analytics for 99.98 percentage of Oracle cloud availability. Now, as a fact, database downtimes cost any huge enterprise more than 9,000 US dollars per minute, which is like typical outage goes beyond an hour when we talk about production databases, which are big in size and complicated in architecture. So it takes about 60 minutes to fix a problem. That costs about more than $700,000 per incident if we calculate the math per minute wise. So our machine learning solutions, they transform the Oracle Cloud reliability based on the implementations across, you know, hundreds of enterprise throughout the globe. So we are going to talk about it. So as an introduction, yeah, this is what it is. So like I said, the cost of the downtime is more than $9,000 per minute for average production issues for a database, and which lasts for more than 60 minutes. Even if it's a small problem, the limitation and the mitigation to solve the problem, the finally fix and implementation, and that takes this much time, which costs more than $7,000 per incident as a total finance impact of running a database with 99 more than 99 percentage of uptime. Now, what is actually machine learning based anomaly detection? So there are three pillars of this entire concept. First is early detection of a problem. So they say that more than 70% of the problems can be identified within like 30 minutes of before they're happening, like space getting filled, CPU getting choked to more than 99%. So there are different examples like that. So if we detect that early, we can prevent that early. Okay. Preventive action. So, you know, can that preventive action be immediately followed and to get the fix available? That's the action to be taken. Now, improved uptime is the solution, the outcome of pillar one and pillar two. So if we do one, two, we have the improved uptime for our database. So for machine learning, what we need is we need to ensure the deep learning of the performance matrix is done by the database and the entire solution to deliver. So there is a pattern recognition is the first step into it. Like I mentioned in the few slides before, pattern recognition, like if there is a month end or quarter end or there's a peak load of application workload going on. So space or gets transaction log or archive logs start getting filled up quickly. So if there's a pattern to it, like on few days of a month or a week, if something like that happens, so recognize that pattern, do the action immediately. Do and recognition should not be in a delayed manner or like 30 minutes or 1 hour. It should be quick enough, like an interval of 5 to 10 seconds, so that the pattern recognition can be identified and action can be taken immediately. There are invisible signals also, which is called, you can leverage the neural networks of the entire solution to detect the correlated pattern from the monitoring logs to fix the problem. Now, when we talk about the entire database solution as a machine learning for uptime of 99.9, we have different technologies like Oracle RAC, which is real application clusters, which provide availability and scalability both for the entire database platform to be available throughout the tough times of month end, close end, or if there is a disaster somewhere or one server crashes or something happens to the network, the other cluster nodes are able to cater. So, and with that, to reinforcement learning of the rack will optimize the entire solution. So basically, there are four parts to it. One is monitoring, then learn, optimize, and validate. So to begin with, the monitoring of the log should be continuous performance tracking of each and every log, like when and what happens when the logs are generated, what information is gathered into it. Learn from those information, the logs which are generated, and analyze the pattern and anomalies into it. Like what happens when something happens, like in the log, which can be related to a pattern. Then third is to optimize when you identify this happened and because of this was the analysis done. So what could be the remediation to fix the problem? And then once that is delivered, you validate for the resilience of the database that okay, because of this we did this and did that solve the problem. So it's like feedback of the solution, and that's how we reinforce the learning to the entire database solution. Now moving on to the one of the points which we discussed was neural networks for data guard tuning. So data guard is one, like most of you know who are into database technologies. Data guard is a terminology used by Oracle databases primarily for the standby databases. So they basically keep a synchronous or asynchronous copy of the primary database to a standby side, or in the terms of replication, so that if anything happens to the primary side, the standby can be activated in case of failure, disasters, or crashes and all. So neural networks for data guard tuning is basically synchronized replication. Like archive system should be very minimum delay between primary and secondary, like in sub milliseconds for the replication lag between primary and standby databases. So this will only ensure there is a net zero data loss during failover events. Like the solution is only suitable if there's no data loss, right? We don't want any transaction to be lost if there is a data failover, a database failover between primary and secondary. Otherwise, the solution holds no value if there is a lag which results in transaction loss. So the most important thing is there should be milliseconds of lag between primary and secondary. So as soon as any transaction is committed on the primary, it should be committed or rolled back or whatever happens on the primary, it should be image of it should be on the secondary side within milliseconds of the gap. And second important factor is if we want to achieve this data guard tuning, like with milliseconds of gap, it does not mean that the primary should take a performance hit because of this kind of a millisecond replication between primary and secondary. So with the minimum performance impact on the primary, the secondary should be in sync without any data loss. That is the most important thing, again, after a minimum data loss. Then, of course, the third key point is ultra fast recovery. So, like in Oracle, there is something called fast MMTR. So, like which is whenever there is a failover happens, the failover should be quick enough that the secondary should be available if there is a failover occurring. To keep it simple, we don't want the application to be unavailable while the failover happens. Now, a few seconds or a few minutes of downtime probably is agreeable to most of the enterprise applications because there are very less enterprise applications which demand 100% uptime because there is always a few minutes of downtime. So it's like 99.99 percentage of uptime is agreeable. So like I said, so ultra fast recovery on the standby side is going to still give you a few minutes of downtime, but it should be happening quickly enough so that the secondary or the failover database should be available within few minutes, if not less than a minute. So yeah, that is about the data guard tuning. Now moving on to another important point, it's called ROI, which is rate of return on investment of machine learning based resilience. So what is the return on investment for any enterprise company on all this kind of machine learning and modeling and all? It there has to be a value to everything, right? So with the machine learning based resilience of databases in cloud Oracle Cloud, they claim more than 280% of return of investment, meaning it delivers exceptional financial return across enterprise implementations over a 3-year period. So whatever investment is done today, it's going to give more than 280% of return within 3 years of time. What does it mean? It means the value any enterprise or any organization if from the investment they do on this Oracle Cloud infrastructure, database as a service, or disaster recovery, or any solution. So there is a pretty nice return on investment. The second point is 8.4-month payback. What does it mean is within like accelerated investment recovery with measurable cost saving from prevented outage. So like I said, 99.9 percentage availability. That means there are outages which are prevented by using machine learning, by doing pattern analysis, by digging the logs, by making the analysis of the outages, that what can be prevented, what action can be taken 30 minutes before a pattern is recognized. So it takes about 8 months to start paying back on this machine learning based Oracle Cloud solution. Again, 99.98 per availability is ensures the all the critical systems they are operational for 8,715 hours annually, which is like only a few minutes of downtime is allowed across the industry wide, and there are agreeable parameters through SOX and all the compliance where how many minutes are allowed of downtime to achieve that standard of availability of databases in Oracle or any other technology. So it basically costs minimizes the cost of disruptions. So that's the plus point. So moving to the next important point is what actually how do we do machine learning in Oracle Cloud Computing? So overall it's predictive auto-scaling benefits. So what is predictive auto-scaling benefits? So before going into the technical slides and all, I'll just share one example. Like when a month end happens, we know that there will be a lot of transactions, there will be a lot of reports running in. So there will be a lot of hit on the CPU of a database server. So auto scaling is as the month end approaches and as the system recognizes that okay CPU is started getting hitting the peak, auto scaling can enable add few CPUs more as the demand grows. So that's the predictive auto scaling for a database. Similarly for memory, similarly for storage, if there is a store growth of databases happening very high at a very high rate, so the system should be auto scaled enough to add more space or at least give the alerts for the system engineer to provision more space. So that gives some prediction for it. So that actually helps in avoiding many outages. So coming to the what we have in the slide is for auto scaling benefits. So one is resource optimization, second is cost reduction. So resource optimization is machine learning models reduce over provisioning by 47% while ensuring capacity for unexpected workloads. Like I said, we don't want to auto scale 24 by 7, 365 days, right? We want to auto scale only when the peak load comes, which can be predicted. So by doing this, by machine learning models, we can reduce over provisioning by almost 50%, if not more, while ensuring the unexpected workloads can be catered. So not always provision higher CPU memory compute to the server, but whenever the prediction is there, then it should be there. Otherwise, it should scale down. Second is cost reduction. So everything has a value, right? So when we do auto scaling, it's per CPU, per memory. Any cloud organization will charge accordingly if it is not done predictive auto scaling or downscaling. So by using machine learning, we can reduce the cost depending on the predictive workload. So intelligent storage tiering based on access patterns decreases cost by 60%. So if there is no load on the servers, there's no workload, there's no prediction, downscale the infrastructure. That's what it means. It helps in reducing the overall cost. Moving to the next slide. So here we are discussing about the case studies of 99.98 availability of the enterprise solutions. So finance services, healthcare, retail, these are, you know, few of the top industries where Oracle Cloud Compute is utilized, and there are benefits of it, like more than 99.98 availability, which helps all these organizations, be it finance, healthcare, retail, grow their business on day-to-day basis because there are no outages. They can cater to their customers round the clock, 24 by 7 across the geographies because Oracle provides multi-region cloud-based solutions where there is no outage and things are available in the matter of few seconds or minutes. Moving to the next slide. So scalable AI framework. So this is what we are talking about, right? So cross architecture compatibility. So it's not only Oracle Cloud which is to be point of discussion here. There are multiple solutions like Azure, AWS, Amazon Cloud, GCP, Google Cloud, IBM Cloud. So machine learning cuts through all these scalable AI framework to get what information is required for the enterprise solution to work efficiently, effectively. Second is automated anomaly detection. So it's not that manually these have to be analyzed by DBA or an engineer sitting there, but there are automated jobs which can be scheduled to capture the logs and information, and later on analysis is done for to be able to publish the reports and boost the operational efficiency overall. It's all about efficiency, right? Next point is engineering productivity. So it frees data teams from manual process. Like I said, it's all automated jobs. Once the jobs are there, you can customize the jobs as per your need, and you can enable the focus on high priority task and innovation, right? Other than the mundane manual jobs. Now, coming to the last topic of the discussion. So, transforming database resilience. So, there are four steps to it. You discover the problem, identify the pattern, you implement the solution using deploy machine learning driven monitoring and optimization tools. Then you optimize what you have learned from there. And then you you achieve your 99.98% availability while reducing the overall running cost of the entire enterprise architect solution. Yeah, so team, this is about the presentation. I thank you for all your time and listening to me. You have a good day. Thanks. Bye.